Hello, and welcome to BIM Workflows for Autodesk Infrastructure Suites. My name is Dino Lustri, and I will be demonstrating for you a variety of workflows that will help you recognize the advantages of some of the tools included in the suites. As a design professional, I often receive or have access to data that is not in the form of a familiar AutoCAD drawing. Without purchasing many expensive software applications to read this data, I need a set of tools to integrate all of the data sets into an environment where I can perform my designs. Autodesk has provided us with their infrastructure design suites for just this purpose. I will demonstrate a variety of workflows that a typical design professional may encounter in their day-to-day efforts. Let's begin by taking a look at a variety of different data sources that you could receive from your local county. I have received or downloaded from a local county an aerial image that's quite large, but you're going to see that the way InfraWorks uses this file, that it doesn't cause any problem with performance. Other data you might receive from the variety of sources are our shape files. For example, centerline information, which is literally just the center lines, but we're going to be able to visualize this in the software in a manner that makes it look like a road. Other information include contours, geotechnical data, hydrography, and then there's even additional data. In the state of Ohio, there's a website dedicated to aerial LiDAR. So this is information that was flown and provided to the entire state and anybody who has to do work in the state. These files tend to be quite large and they are quite detailed. So I will show you how we can take advantage of this stuff. So launching InfraWorks gives you an introduction screen that allows you to create a new project. As we give this project a name and click OK, an environment is going to be set up, which basically constitutes the entire world. So we're going to have to narrow it down a little bit. So as you can see here, I can rotate around the sky and there's nothing to see for miles and miles. So what we do is we attach data to this model in the form of which we received. So one of the data types is contours. And here I have the topo shape file, and it's about 52 megabytes. Now I've connected it, but we need to configure it. So as I assign what I'm going to use that data for, terrain, what coordinate system or datum I'm using, and finally, some of the data that's embedded in that contour data can be very beneficial to me in utilizing the data as a terrain. So I click close and refresh, and after a couple of moments of processing, that information is going to be presented to me in the form of a terrain surface. Now, there are many other types of data sources that we can add to this list. As that starts to complete, we can see the results here pop up after a moment. And as you can see, I rotate around, zoom into it, and it looks rather bland because there's no other surface features to give us a point of reference. So I'm going to add an aerial image next, simply to give it a little bit of an impressive look. So now we're going to go after a raster image, and we are going to hunt down the aerial that I received. Again, this is 623 megabytes, and it ends up processing quite quickly. I double-clicked on the wrong item there. Again, we need to tell it what it is. It actually recognized it. Assign a coordinate system. And at this point, we can close and refresh. Now, the information will drape onto the surface, and you would be able to see the actual reveal from the terrain and the 3 dimensions of the or the image actually overlaying onto the surface that we created. So there is a nice appearance of the data that we just imported. Let's add a little bit more data. Since we have it, I'm going to hunt down a shape file for the center lines. And this one's very small, but it spans throughout the whole county. and it's been added but not configured. So I go in, I tell it what it is. And in this instance, it's a road. I'm going to tell it again what coordinate system we're working on. And here we're going to have and use the drape function so that it lays on the surface wherever it is. So after doing that, that file gets added. And after a couple seconds of processing, I will show you what that looks like. As I zoom into some roads here, you can kind of make out that the roads are there. They're actually modeled. If I go over here into a subdivision area, you can kind of make out all these various roads are set up simply from the centerline shape file that came from a county. We can get all that. And by the way, these are these can be customized quite a bit, so they don't all have to look identical. You can take time to customize them. You can even customize it based on the metadata that's in those lines. So this can appear different if the road is classified as a different, like a 4-lane road versus a 2-lane, et cetera, et cetera. We're going to add a little bit more data. This time we're going to add water. So I hunt down the shapefile for water. I assign information to it, like what it actually is going to be used as. So as you see here, it says water. I make sure that it's not draped this time. And after a couple moments, you will see the results of the water appear on the screen, which gives it a nice look. As we zoom in and I rotate around, you can even see the sun reflecting off of the water's surface. So all of these tools and all of this data can be easily assembled in InfraWorks to give you a visualization that's quite simple and yet very functional. And I'll show you that here in a moment. We can very easily supplement the data when we know that there is data sets or items that are missing. For example, here in the golf course, there's a pond there, and as you can tell, it's a bit brownish for the most part, so it doesn't look that nice. There's a variety of tools in InfraWorks that allow us to actually create our own surfaces here, and so by doing this effort, you can see I'm creating an approximate outline, and I'm not really trying to stay in the lines. I'm just trying to do this quickly. And after clicking on it and clicking off of it, you can see that I've added a water body. And of course, if I took the time to really get that accurately, actually, I could have imported line work from CAD. So if I had absolute field collected efforts, I can add those and bring those in as well. So needless to say, there's a ton of function here in InfraWorks that allows you to visualize very quickly. Buildings can occur as well. Now, this particular county did not provide me with building data, but I could have added buildings with elevations according to whatever info I had, whether it be field observation or simply just arbitrary building heights, just to give me, a feel for the surrounding area. I'm going to change gears here a little bit and launch a software called Recap. The purpose of Recap is to allow me to bring in the point cloud data that I downloaded from the state website. So as you can see here, I'm highlighting the LAS files that I received, clicking Next, and there is the ability to assign a coordinate system here, which is important if you want to bring this data into the InfraWorks environment. So if I start typing in the letters of the coordinate system that I know this to be from, I can start the import. Now, as you can see here, while these files are about 10 megabytes each, they're processing quite rapidly. And once they're done, you can simply click Launch Project, and you can see the results here on the screen. Now, the one caveat to this is that this was not classified data, so what you're seeing there is quite a few trees. And if we want this for terrain modeling purposes, those trees are going to have to go. So for that, we're going to use Civil 3D. But before I do that, I'm going to simply do a quick save as, place the information in our folder where the OSIP data resides, and just call it recap. Now we're going to bring in that same file into Civil 3D. So starting with an empty new drawing in Civil 3D, if we go over to the prospector and you see point clouds, we'll create a point cloud. It's called LiDAR. And we are going to use a LiDAR point classification as the style. I'll explain that more here in a moment. We're going to go hunt down those files. These are the same files I just brought in. And if I wanted to take the time here, I could assign the coordinate system. I'm going to go select a location for them to be. Then finally, we are going to go ahead and click Finish. Now, this process takes advantage of a multi-core processing CPU, so it works in the background while we can continue working in Civil 3D. So with that, while that is working, I'm going to show you yet another way we could take advantage of Civil 3D while that gets calculated. Now, one of those ways is called map import. Now, when you do a map import, we have the ability to hunt down contour data in the form of a shapefile. And when that data comes in, it doesn't have elevation data assigned to the lines. So here, we're going to make sure that the elevation data comes in. That way, we can take advantage of it in the creation of a surface in Civil 3D. So that process is going on as well. All of the contours are coming in from the file that I had, and at the same time, it's being translated or converted into actually a polyline that has an elevation. Anybody who's done that kind of connection before can probably attest to the fact that if you just do a simple import, you end up not seeing the information at the proper elevation. So when I come in here and zoom in and I do a list of one of these lines, we now have elevation. So this effort gives us the ability to create a surface out of the data set. Now the point cloud was finished, and as you can see, it came in. Now, right now, it is a little bit difficult to see here, but as I zoom in a little bit, maybe you can see the variety of points in here. I'm going to click on them, and you can see up here on the contextual ribbon that we have the ability to change these numbers. So I'm going to lower it down to 15, and I am going to edit the style so you can see what kind of modifications we can do with the classification. So as you see here, I'm going to leave ground and simply turn off every other one. Now this isn't the best workflow in Civil 3D, but we can set that up at a later time as part of a style. So if you wanted to do ground creation, you would see that. So as you see it right now, there are a bunch of brown dots representing the point cloud for the surface. And if I click on Add Points to Surface, I can create an EG LiDAR surface. Click Next. Click the entire cloud is fine. Next again, and now 80,000 points are going to be used to generate that surface. Now that was quite quick, and we're seeing a little bit of discrepancy between the point cloud and the software that generated the contour data for the county. Now, what does that mean? That just means that their contour data was post-processed substantially more than ours was. That's really all that it means. But the part that I'd really like you to see here is that when I click on the Civil 3D surface that was generated, you are ultimately getting a surface there that does not have any trees. Now we can take this surface in Civil 3D and export it to LandXML. And at that point in time, we'll be able to bring that in to InfraWorks once that's done being exported. So back in InfraWorks, just to make you aware, you have the ability to bring in the point cloud that we exported from Recap. We also have the ability to bring in the land XML that we exported from Civil 3D. Now, obviously, in this particular case, I had the contour data, which I took advantage of here, but this is just to prove to you that if you only had one kind of info or another, ultimately any of them can be brought in from a variety of sources. So now at this point, I'm going to export some information and bring it into Civil 3D. So I'm going to zoom in to this entrance area here. And you can be in a three-dimensional view if you'd like, but this effort actually can be done in any kind of way. So if we end up doing the export function, which just going through the menus here, you can see the variety of different tools that you have. Ultimately, we can do an export to an IMX file and do it via a polygon. Now, if you watch what I'm picking here, it kind of is a neat three-dimensional plane. And as you can see, I'm cutting across the fairway here and back across the road. So just that area, and then a double click will finish it off. And you can dictate what the target coordinate system is as well. So as long as you point to the location of where the export is going to go and click export, that's all you need to do in InfraWorks to take your information from this environment and get it prepared to bring it into Civil 3D. Now in Civil 3D, we can easily bring in that IMX data from the Insert tab, simply selecting it and zooming into the results. So what we have are alignments in red. We actually have the terrain, which came in the form of a DEM, a digital elevation model, and we know that not to be as good as our TINs from field collection, but it's still a surface. It's still from that effort, and even the pond that I drew came in. Now, in addition to this, I'd like to show you another tool in Civil 3D that would allow you to juggle data that comes from a geotechnical engineer. The geotechnics module was added in the last release, and here we can import data. First thing I'm going to do is hit the Save button, and once you click Import, you're going to get a dialog box that allows us to bring in the information from a CSV file. So if I pick CSV, browse for the whole data, browse for the geology data, and then it is a comma delimited file. And ultimately, we're going to have the information that comes in. And if I click Import, it's going to come in the form of what appears to be Kogo points, but upon closer inspection here, you're going to see that it's more than just Kogo. So if I do an object viewer and start rotating that in 3 dimensions, you start to see the actual data. And it is separated into the various strata. So now we can click on Borehole Manager and see the various information. You can turn individual boreholes on and off, see different information, stylize them. We can also go to Strata Manager and show the different surfaces that are generated by the boreholes. So for example, the fill is actually in 28 of the boreholes. There happen to be 28 of them. And if I click Display Top, you will see a surface appear that represents that elevation, that level. So quite a few tools that are useful for a variety of different data sets that are in the suites. Thank you for watching my demonstration on BIM workflows for Autodesk Infrastructure Suites. If you already own a suite, the only obstacle to taking advantage of these tools is learning how. So give us a call and let us help you optimize your workflows with the software you already own. If you don't own any of the suites and are interested in learning more about any of the software mentioned today, please contact us and we'll perform a custom demonstration that addresses your specific requirements. This is Dino Lustri with Imaginate Technologies, thanking you for taking the time to learn about Autodesk Infrastructure Suites.